Hello guys, welcome to my YouTube channel Olympiad Edge. Hopefully you are will be fine. Today we are given with a very nice trigonometric equation which is given as 2 cosine square x plus 2 sine square x is equal to 3, and we have to find the value of x. All values of x we have to find here in this question. So let's start. To solve this, first we will use trigonometric identity which is given as sine square x plus cosine square x is equal to 1, and from this we can write it as sine square x is equal to 1 minus cosine square x. So putting this value in above equation, we will get this equation now will become 2 raised to power cosine square x plus 2 raised to power sine square x is equal to 1 minus cosine square x is equal to 3. Now we can separate the term from here, and it can be written as 2 raised to power cosine square x plus 2 raised to power 1 times 2 raised to power minus cosine square x is equal to 3. Now we can write it as 2 raised to power cosine square x plus 2 raised to power 1 is equal to 2, and if we take this term in the denominator, this negative power will become positive and we will get 2 raised to power cosine square x is equal to 3. Now multiplying both sides by cosine square x, we will get 2 raised to power cosine square x times 2 raised to power cosine square x plus this will cancel out when we multiply with 2 raised to power cosine square x, and we will get 2 from here is equal to 3 times 2 raised to power cosine square x. Now we can rewrite it as this will become 2 raised to power cosine square x whole square plus 2 is equal to 3 times 2 raised to power cosine square x. Now to solve this, we will take let y is equal to 2 raised to power cosine square x, and now this equation will become y square is equal to 2 y square plus 2 is equal to 3y. Putting y is equal to 2 raised to power cosine square x, we get this, and we can see that now it is a simple quadratic equation. Rearranging this equation, we will get y square minus 3y plus 2 is equal to 0. Now factorizing this, we will get y square minus 2y minus y plus 2 is equal to 0. On adding minus 2y minus y, we will get minus 3y, and when we multiply these two terms, we will get 2 into y square is equal to 2y square. That is, multiplying these two terms, we will get this product term. Hence, these are the right factors. So taking y common from these two, and we will get y minus 2, and taking minus 1 common, we will get y minus 2 from here also, which is equal to 0. Now again taking y minus 2 common from these two, and we will get y minus 1 is equal to 0. Now from this we can write it as y minus 2 is equal to 0, or y minus 1 is equal to 0, and we find the value of y as y is equal to 2, and from this we find y is equal to 1. Now by back substitution, by putting the value of y again, that is y is equal to 2 raised to power cosine square x that we take earlier in the start. So putting this value, we will get 2 raised to power cosine square x is equal to 2, and from here we get 2 raised to power cosine square x is equal to 1, and from this we find the value of x as, from this we can write 2 as 2 raised to power 1, and comparing left hand and right hand side we get cosine square x is equal to 1, and simplifying this, cosine square x minus 1 is equal to 0, and now we can write this 1 as 1 square, and using the formula a square minus b square is equal to a plus b times a minus b, we can write it as cosine x plus 1 times cosine x minus 1 is equal to 0, and from this we can conclude that cosine x plus 1 equal to 0 and cosine x minus 1 is equal to 0, and from this cosine x is equal to minus 1, and from this we conclude cosine x is equal to plus 1. So these are the values of cosine x from this equation, and from the other equation we can write it as, from this equation we can write it as cosine 2 raised to power cosine square x is equal to 1, and 1 can be written as 2 raised to power 0. Something raised to power 0 is equal to 1. So from this we can write this as, and on comparing left hand and right hand side, we conclude that cosine square x is equal to 0, and from this we find cosine x is equal to 0. So these are the three equations to find the three roots of the given equation. Now we will find the values of x from these three equations as. Now from this equation we conclude that, as we know that cosine of pi is equal to minus 1. Similarly, we can also write as cosine of 2 pi, which is also cosine of 3 pi, which is also equal to minus 1, and similarly cosine of 5 pi is also equal to minus 1, and cosine of 7 pi is also equal to minus 1, and up to so on. In general, we can write it as cosine of 2k plus 1 pi, which is also equal to minus 1, where k is equal to 0, 1, 2, 3, and up to so on. So on all these angles, the value of cosine is equal to minus 1. Actually, these are angles are the cycle of cosine, and actually all these angles are the angles on negative x-axis. So we can write it as this 2k plus 1 pi. 2k plus 1 pi is a general angle on negative x axis, and on negative x axis the value of cosine is 1. So from this we conclude that cosine of pi is equal to minus 1. This implies that cosine of x is equal to cosine of pi, and this implies that x is equal to pi, and according to the journal we can write it as x is equal to 3 pi and x is equal to 5 pi, or x is equal to 7 pi, or in general we can write x is equal to 2k plus 1 pi, where k is equal to 0, 1, 2, 3, and up to so on. So this is the first root, first value of the x, and now for the other roots, similarly in the same way we solve the other two equations. Now from this, as it is x is equal to cos of x is equal to 1, similarly we will write the values of cosine, where cosine is equal to 1, and we can write it as we know that cosine of 0 is equal to 1. So from this we can write cosine of x is equal to cosine of 0, and this implies that x is equal to 0. Or to generalize this value of x, we can write it as cosine of 0 which is equal to 1. Similarly, cosine of 2 pi is also equal to 1. Cosine of 6 pi is also equal to 1. These are the angles on positive x-axis, and these are the cycle of cosine for the value of 1, and in general we can write it as cosine of 2k pi, 2 pi k or 2k pi, and on all these angles the value of cosine is equal to 1. So and here k is equal to 0, 1, 2, 3, and up to so on, and this 2k pi is a general angle on positive x-axis. So from this we conclude that as in the start we write x is equal to 0. Similarly, we can write as x is equal to 2 pi, x is equal to 6 pi, x is equal to 8 pi, and in general we can write it as x is equal to 2k pi, and where k is equal to 0, 1, 2, 3, and up to so on. So this is the second value of the x from this equation, and now for the third general value of x we will solve the equation number 3, which is given as cosine of 0 is equal cosine of x is equal to 0, and from this we can write it as cosine of pi by 2 is equal to 0, and on comparing cosine of x is equal to cosine of pi by 2, and this implies that x is equal to pi by 2. This is the value of x. Now to find the general value of x, we can write it as cosine of pi by 2, that is this pi by 2 is the angle on y-axis, and cosine is 0 on y-axis, so we will write all the angles on the y-axis, and these are cosine of pi by 2 and cosine of 3 pi by 2. Similarly, cosine of 5 pi by 2 and cosine of 7 pi by 2, and in general we can write it as cosine of 2k plus 1 pi by 2. On all these values the value of cosine on all these angles the value of cosine is 0, and so we can put here, and after comparison we can find all the values of x as x is equal to pi by 2, and x is equal to 3 pi by 2, and x is equal to 5 pi by 2, or in general we can write it as x is equal to 2k plus 1 pi by 2, and where k is equal to 0, 1, 2, 3, and up to so on. So these are the three roots of this given equation in general form, and where k is equal to 0, 1, 2, 3 in all these three roots. Thank you so much for watching this video, and please subscribe my channel for more interesting videos. And after watching this video, if you have any other easy solution of this question, please share with us in comment section. Thank you.